All right, let's get going here. Um, so welcome to study hall. Looks like we got a few people in here already. It's good to see. Actually, my looks like my YouTube metrics are off here. Let me just reload this page. Maybe that'll update that. Still doing kind of system check stuff here. Okay, that's better. It's loading now. Okay. So welcome to study hall. This is a place for you all to bring your questions. If you have any questions, especially from around Learn, feel free to pop them into the chat. And I'll be happy to take them. Just include a link to the question and Learn so I can find it quickly, and that'll help me help you with a solution. Yeah, happy Friday. Happy Friday to you too. Happy Friday, everybody. um, yeah, so let's get going into things. So, I'm kind of, I'm still here. I've just been spending like the half an hour, kind of the last half hour, preparing and kind of debating whether to go through Code Wars problems or go through the material in Learn here. Looks like we got one challenge here in common data types. I'm kind of leaning towards just grabbing a couple Code Wars problems and just talking about workflow stuff and problem solving and just jumping into it and seeing if I can get one that'll stump me. And yeah, just going from there. But yeah, do feel free to put in a question, and if I see a question, I'll just kind of wrap up whatever I'm doing and then take it as soon as I can. Since I'm not seeing anything at the moment, I'll just jump in with the Code Wars problem. So, I've done a couple Code Wars streams recently, so bear with me if there might be a little bit of redundancy here, but I'm going to kind of walk through kind of, once you get an account set up, like how to use Code Wars. So, this is a resource that I like. It's by no means the only resource that I would recommend. If you just here, we'll just look at this. Python practice, uh, Python practice sites, or we could even do coding practice sites, Python coding. Oh, we'll do that. So we could do a web search here, and then inevitably we'll find some, the 8 best interactive, 12 best coding challenge websites, So there's a lot of things like Code Wars. We recommend Code Wars because Tovio and I will recommend Code Wars because that's what we're both familiar with. We've both used it fairly extensively, but by no means is it the only one or, like the one you have to use. There's a lot of good other ones out there, so you can go just play around. But whatever your coding practice, excuse me, your coding practice site of choice, will be, at least broadly similar to this. So, the workflow stuff you could look through as well. So, so basically, when you log in, I won't go through like creating an account because it's sort of its own thing, but creating an account will ask you to solve a simple problem, and it's kind of a silly problem. They show you some code and they ask you to fix it. It's a function that is missing a return, so you just need to put in the return in the proper place. So if you're having trouble with that, just put in that return in the right place and you can set up your account. You can look up that solution as well. But once you get your account set up, it'll take you to something that looks like this. Now, my account is developed and I have some achievement things and some various other things. But yeah, it tells me my languages and it like gives me a challenge. Yeah, you can just choose to do whatever challenge it's going to give you next. But what I always like to do is just come to kata here. So that's the magnifying glass icon. I know, let me see if I can, apologies, let me see if I can make this bigger real quick. Just realized that's so tiny on OBS. And then let me resize my camera. There we go. I'll just kind of leave this random scene composition like this for now. That's okay. I still have the other one here. So if you're on, if you're looking at this, you'll go to kata, which is the magnifying glass, and then just in here they have some search parameters. You can search for various things if you want. I never really use those. I just come to the difficulty. The difficulty is, I think, a little counterintuitive with Code Wars. The difficulty is ranked 1 through 8. The 1s and 2s are very, very hard. I think most people intuitively look at the 1s and 2s and think those are the easy ones, but they're actually the hardest ones, and they are, some of them are very hard. 8s and 7s are the easiest, so it's the difficulty grading is maybe kind of backwards from what you might anticipate it to be. So you can just click on a difficulty level and it'll just reload and show you all the ones of that difficulty level. Or you can click and drag and you can see it's highlighting multiple different ones. So let's just see 8s through 7s. And then from here there's no big science to it, but just look for one with the name that seems interesting to you. And I do recommend, I have people ask me a lot, like, how do I find, like, one specific question that I get a lot is like, how do I find dictionary problems or list problems in Code Wars? I don't think there's a filter for that, and I would recommend not really using Code Wars for that. If you want to know something specific, about a specific feature, just do a web search for it and look for specific examples regarding that feature. Our website, the Learn material in Galvanize's website, I think is oriented more around that, like, here's an idea and we'll explain that idea. Code Wars is more oriented around, like, here's a random problem, and it kind of gives you the ability to, like, think about a random problem or arbitrary problem and, like, pull in different elements, and sort of the ability to, like, discern which elements are necessary to solve the problem is part of the challenge, I think. So I do recommend just finding random problems like this, or just doing your own projects, your own coding, and just getting, like, kind of general practice. So I think the best way to do that is just find one with a title, find a problem with a title that looks interesting. Just kind of judge the book by its cover, as it were. So what's this one? Scaling squared strings. That kind of sounds interesting. Let's go with that one. Let's see what this one's about. So this will just give you a little, overview of the problem. You'll just hit train up here, and you get that same overview over here as well. Cool. All right, so now let me actually, I might as well just make this full screen here. Now we're seeing these several windows here. You have your problem statement on the left here, and I know that the text is a little small. I'll see if I can blow that up a little. Yeah, that's better. You'll see the instructions, the problem statement on the left here. So obviously just explain what the question is asking you to do, what the problem is asking you to accomplish. This is also your output window, so you have these two little tabs. You have a little REPL area, read, evaluate, print loop sort of area here. This is not really a complete REPL environment, so I would recommend not using this to actually do. Don't use this environment as the place where you'll actually solve the problem. Come to your actual environment, and in my case, I'm going to use Atom, but you'll use VS Code or Jupyter, or if you're still on Replit, use Replit, and that's fine too. So yeah, you have this solutions area. Once you're done testing your code in your own environment, you'll paste it into the solution area. And then you have this area down here where they show you a few sample tests. And here, let me get my camera. Well, I'm just going to get rid of my camera for this scene. So down in the bottom right, once you paste in your code and you're pretty sure it's working, you can click test. If you click test, it will run these tests. It'll run the tests that you see in the window. If you click attempt, it'll run these tests, and it'll run a bunch of tests behind the scenes that we don't have access to, that we can't see what those tests are. So they're written and they're behind the scenes, hidden away from us. So if you click attempt, it'll run extra tests. Yeah. So basically, the way I recommend starting a problem, what I like to do, you can give it a read first, but see if it's a problem that's interesting to you or not. Oh, I just copied it. Okay, cool. So I just copy pasted. Oh, oops, I'm on the wrong scene there. Sorry. I just copied from Code Wars and pasted into my environment here. Now I'm just gonna kind of make sure that everything looks right. It looks like, okay, so we've got these lines here that were kind of formatted in this markdown cell in here, but that's okay. We've got some examples, and I wonder if a lot of times when you see something that says example, it gives you all the information that you need to construct a complete test. So we'll see about that and see if we can construct some tests out of that as well. So I'll bring in my problem statement in here, and then what I'll do is I'll copy all the tests in here, and I'll paste those in. So this is all about testing, about making sure that you have some tests for your function that you're writing, and then knowing how to implement those. So there's kind of a bit going on here, but we're going to convert these into really simple tests. So let's just see. Our function is called, what's it called? Scale. It takes in string k and n. Okay, so let's just write that function head real quick. Def scale takes in a string k and n. Okay, I'm just going to pass for now, and then I'm just going to look through here for any line that's actually directly calling my function, and any other line for the most part that's not calling my function, I'm just going to delete, right? So I don't need this testing function here. I don't need these. I'm not going to delete these two variables here because they're actually being used inside that function. It's kind of nice. These are really long, so it's kind of nice to have these broken out into other variables so that line doesn't get too long. Then basically whatever is calling that function, I'm just going to change it to print. And the different tests will be written differently. They'll be kind of written in different paradigms, and they'll all look a little different, but at the end of the day, they all need to do the same thing. They all need to take in the result of the function and compare it to an expectation, right? So in this case, it's expecting this R string to be produced. So I'm just going to print these out, and that'll keep it nice and simple. If you want, there's various other things you can do to like, verify that you're getting the right result and whatnot. But yeah, this is gonna be nice for now. Is just keep things simple. Okay, cool. So now we have a basic structure of testing, and I haven't even read the problem statement yet, so I'm going to look through here and see if there's any other examples that I can turn into tests. And when I'm looking for things to turn into tests, let's talk about, well, why would I do that? Well, a lot of times, the thing that helps me get the sense, the thing that helps me the best get a sense of what a function is supposed to do is the tests. I find that I can read a problem statement, and if I can understand it well enough to write tests, then I have something that I know I need to build for, right? Whatever function I write here, it better do this, right? It better, for these inputs, it better give me this output. So thinking about it that way actually, to me, really helps me understand what it is I'm supposed to be doing. So that's sort of the central idea, or that's like the central thing that helps me get started. And writing tests is sort of the medium for that, right? And then, so basically, all I need to look for when I'm going through something, I'm looking for things to turn into tests, is something that gives me a pattern, like for a given input, I expect some output. So I saw some. Yeah, here's some examples where it says example. Usually, when you see something that says example, it'll give you an example like, okay, if we gave it this input, we would expect to have this output or something like that. Or we can deduce that from these examples perhaps, but we'll see. That these might not be that. I haven't read through them. So now we'll actually read the problem statement. So you're given a string of n lines, each substring being n characters long. Oh, interesting. Okay, so this has 1, 2, 3, 4 lines, and it looks like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so it has as many lines as it does columns, I guess. That's interesting. Okay, so you're given a string of 4 lines, each substring being n characters long. For example, so this is great. This is great. For example, here's a valid input. So I'm going to do Control D. If you're on Mac, it'll be Command D. So I'm going to see, yeah, so it looks like this input. So what I did there is I'm just looking here and I'm thinking, well, maybe they're giving me this example in the problem statement. Maybe they're also testing for this example. Sometimes they will, sometimes they won't. So it looks like I just did Control D. Like I said, if you're on a Mac, you can do Command D to do that bulk selection. I'll select it once, and then Control D, and it looks like this is being used as an input into the function, which means they're testing for it. So that kind of makes it easier. So for example, here's an input. So you're given a string of n lines, each substring each substring is n characters long. For example, valid input. So we will study the horizontal and vertical scaling of this square strings. Of this square of strings. Okay. A k horizontal scaling of a string consists of replicating k times each character of the string except the \n, the new line character. Okay. So a K horizontal scaling consists of replicating. Okay, consists of replicating K times each character of the string except for the new line characters. So I think what they're saying is kind of like stretching it. So, for example, two horizontal scaling of S is AA, BB, CC, DD. And let's see what our input was. Oh yeah, here it is. AA, BB, CC, DD. Duh. Okay. So it just means double every single one. Interesting. Okay. Okay. Oh, this is kind of sandwiched together there. A V vertical scaling of the string consists of replicating V times each part of the squared string. Each part. I'm imagining part refers to each row, so each substring between the new lines. So example, 2 vertical scaling of S gives me A, B, C, D, A, B, C, D, E, F, G, H, E, F, G, H, I, J, K, L, I, J, K, L, M, N, O, P, M, N, O, P. Okay, so vertical scaling replicates the lines. Horizontal scaling replicates the characters. Okay, interesting. So we're kind of stretching the string widthwise and or lengthwise. Okay. So function scale string kv. That's interesting. So k is for horizontal. I don't know why that wouldn't make that h, but so be it. What do I know? We'll perform k horizontal scaling, and you know what? I'm writing this code, so unless I get an error that tells me that that parameter has to be called k, I'm going to call that h. We'll perform k horizontal scaling and v vertical scaling, and I think it needs to happen in that. Well, I guess it doesn't matter which order it happens in, just so long as both happens. And I wonder, maybe I could break this into two other helper functions where I could do a horizontal scaling function and a vertical scaling function. But I don't know. So example, A, B, C, D, E, F, G, etc. Scale A, 2, and 3 will stretch it widthwise by 2 and triple its length. Okay. Great. Cool. Horizontal. Okay. I was trying to read that. I was like, am I reading? I was like not trusting my eyes. I was like, horizontal? Yeah, I think that's what K for horizontal, because that makes sense, right? That's code words for you. Excellent copywriting all around. No. Okay, cool. So basically it's telling me that this string on the left, I guess, should turn into the string on the right. And that's for K2 or H2 V3. And let's see what we got here, H2 V3. Okay, great. So it looks like that test that's described is actually being tested for. It's the first test here. Looks like we've got this edge case, and you know what? I just want to handle that right out of the gate. And, our logic might handle it naturally, but I just kind of want to, like, ignore it, just kind of set it aside, solve it really easily for now. And it may be the case that our logic won't handle it, so we may need to do this anyway. So might as well check it off the list since it's obvious. So I'll just say if string equals empty string. I could, as a variation, I could do not string if not string. Empty string in this context is falsy, so it can be understood as a false value. And then I want this to run when it's empty, so not false is true, right? But I kind of like to do this. I kind of like to say if string equals empty string. I think it's just kind of clearer. It's more explicit. I kind of try to avoid using truthiness and falsiness, other than just using true and false values and expressions that explicitly and clearly evaluate to true or false. But it's just a personal preference. So if the string is empty, I want to return empty string. Okay, and we'll just do that. Okay. So this gave us none, and we wanted all this here. So I think what I want to do, just to kind of break things out a little bit, I'm going to call this imp for input, exp for expectation, and we'll call this res for result. And that'll be that. So what I like to do is say res equals exp, and then I'll print res just so I can see the result. And the reason I like to do this is I get a true or false here if res and exp are equal. True, if it says true, then I know they're equal and it's passing this test. And then if it's false, I can see res as well and see the result that I got. And if it's, then I can analyze how it's different, and from there I can start deducing why it's not working. So I think I'll just do this for the other ones as well. So the input for this one is an empty string. The expectation is also an empty string. And then our result is the result of that right there. Okay. Oops. I guess we don't need an imp for this one. We don't need an input because we got the input right there. And then for this one, let's just do this. Oops. There we go. Oops, there's that. Okay. Cool. So I think I did this correctly. Name A is not defined, of course. Imp. Okay, false, true, and false. That's interesting. Huh. We're getting a completely different kind of answer. For both of those. That's kind of concerning. Why is that happening? So I'm kind of looking at this, and I must have done. Oh, I see what it is. I see this. This is getting none, and this is getting a single element tuple with none in it, and that's because I have a comma here that is turning that into a tuple, and I didn't mean to. I forgot to delete that comma. Just just a leftover artifact. Okay, so I have my edge case passing. That's great. I'll just comment it out because I know that that condition just handles that case, so we can just ignore it. And then from here, this looks like it would be easier to get working first. Let's try that one first, and then we'll try this big one later. I'm going to put my edge case up at the top here. That's just what I like to do. So I'm going to test this one, and then I like to kind of just work on the easy ones first, and kind of work my way up to the harder ones. A lot of times, if you have 4 or 5 tests, you get the first 2 or 3 working, and then the rest will just work. And every time you get one test solved, you can go on and just uncomment all of them and see if they all work. Cool. So we'll do that. Okay. I'm thinking of where to start with this one. So I'm thinking, we could do something, maybe we could do an accumulator. In this case, I'm not doing any horizontal scaling. I'm only doing vertical scaling. So for this one, I'll do Rest and exploit this. So for this one, I got KJ and SH. So why don't I just do a section for vertical scaling? And, oh, I don't think I spelled that right. There we go. That's better. So for this one, I think I am just going to do an accumulator. I feel like there's probably some methods that I could use to make this easy. But I kind of want to just use, I like doing accumulator solutions. I like it because it's just, using a simple set of tools to kind of get everything done. It's kind of fun, and I kind of like demonstrating that kind of coding for this kind of environment and this kind of audience. Because, if you get good at the core tools, you can get done whatever you need to get done for the most part. Okay, so let's just say I want to make more rows. Huh. Should we just do for row in string dot split on, and if we split on new lines, \n. Now let's verify that row is actually giving me what I think it's giving me. Now what I want it to do is give me this KJ and SH. I want it to give me each row. But let's see if that's actually what it's doing. KJ and SH. Looks like it's good. Why only vertical? Yeah, just to cut the problem into pieces. Exactly. Since this test here is only concerned with vertical scaling, you can see the horizontal scaling is 1, so there's no scaling, and then the vertical scaling is 2. So this is a nice simple problem to start with. I'm only concerned with scaling in one direction. So I'm going to see if I can get scaling working in one direction and then the other direction, and then both. So yeah. And then probably as soon as I do that, probably I'm going to look at it and be like, oh, I could do this not in 2 steps. But also, I don't know, maybe I'll look at it and not have that realization and be like, oh, maybe I do need to use 2 steps. Or maybe using 1 step isn't obvious, but I will have at least arrived at a working solution that way. So I'm just doing vertical for now, but I will be doing horizontal eventually. Cool. Oh yeah, we are doing horizontal first. Yeah. Excuse me, vertical first. Okay, so for row in string.split, string.split on new line. I'm going to print rows. So we are getting the correct rows. This is actually producing row. So I think what I want to do is, I guess I could do ACC. No. ACC. There we go. ACC plus equals row times n. Ah. Okay. You know what? Let's do this. So ACC is going to be an empty list, and we'll turn it back into a string. So we'll see ACC.append. And the reason for that is that the barrier between each append will be preserved as its own element. You know, I'm not just growing characters, I'm growing substrings in a list. And then after that, I can do ACC equals, I can reassign it to a string dot join ACC. So ACC is a list, and then we can do that. Oh, oops. I was like, wait, that's the same problem. I want to join on new lines, so I want to reconstruct those new lines. Okay, cool. So KJ, KJ. Ah. Okay. Interesting. So I wonder if I have to do, let's do this. Huh. Huh. I wonder if I did this. Okay, cool. And then here I can do um, new line dot join that. Oops. Yes. Okay. So KJ. Okay, look, true. So I got that test passing. Great. Okay. Okay, so now I think I want to do horizontal. I'll do horizontal before I do vertical here, and then we'll do vertical after that. So I think maybe we can start. So let's call this. I'm just going to keep these nice and separate. I'm going to call this vertical accumulator, and let's have a horizontal accumulator as well. And I think what I want to do, I'm going to need to go through each character in each row. Okay. So I think since I need each row individually, I have a for loop that does that for me. Okay, so I'll say for row in string.split \n, and then I'll say for character in row. Okay, and then again, print, go ahead and print ch just to confirm that it is what you think it is. KJSH. Okay, and we'll do, let's see. Okay, now KJSH. So this is giving me the correct character. So now I want to maybe so this is actually going to become my new row. Yeah, this is actually going to become my new row. So I'm going to say new row equals, and I think this is going to need to be new row here. So new row equals and do I need to I think we'll do this. New row equals empty string, and then we'll say new row plus equals ch times h times the horizontal scaling. I'm just going to run it. We'll just see what we get. So that didn't break that test. I meant to do this test as well. We'll see what we get for this one. Oh, look, we got true and true. Let's make sure we didn't break our original one. I'm a little doubtful that this is going to pass all the tests in Code Wars, but we are passing all the local tests. We've got some stuff that I'm not using here. HACC I'm not using. VACC I didn't end up needing. I'll just call that ACC again. Okay, so that's no longer just for vertical. This now does horizontal and vertical. So I want to point something out, right? Like the approach that I took is I'm just going to break this into little tiny baby steps, and I'm kind of assuming that I'm going to break it into more steps than I need to break it into. And initially I was like, okay, I'm going to have a looping section for horizontal scaling and a looping section for vertical scaling. And then I didn't need to do that. I just needed this looping structure. And I kind of, but like starting with that paradigm, I kind of got myself to this point. I'm not sure that this is the most elegant way. I'm actually pretty sure it's definitely not the most elegant way of solving this problem. And we'll see in a second here if it's going to work, but it's gotten me to this, like, thinking incrementally has gotten me to this point. I'm not worried about solving this in the most efficient way possible. I'm worried about getting to a working solution. And once I have a working solution, which this is evidently, then I can go back and refactor my code and ask, like, can I do this better? So it's much easier to like build a more optimized, cleaner, nicer solution from code that's working rather than from scratch a lot of times. There might be, you could argue, I think, that there might be some exceptions to that, but, you know, I think it's basically as a basic rule of thumb, it is often easier to solve a problem first and then optimize it. It's easier to do that than it is to just optimize it out of the get-go. And it doesn't really take that much time. In fact, it's usually quicker. Cool. So, in terms of optimizing this, I wonder if we need this edge case. I'm just going to test this out. Nope, it looks like we do need that edge case. But that's interesting. I got all these new lines here. So, yeah, looks like we need that edge case for now unless I kind of refactor my code. We've got our accumulator. I could turn these into comprehensions. I could at least turn this inner one into a comprehension. So let's see how I would do that. So this does need to be a string, but in order to do a comprehension, I have to do a list. Now, I know this needs to be a string, so right out of the gate, I'm just going to string.join like this, and this will be a string comprehension, quote unquote. take the thing I'm doing plus equals with. I'll put that in front. Oops. And then, oops. I'll pull that up front. Delete the colon. Okay, so we just converted that to a comprehension. Let's make sure it passes our tests again. True, true, and true. Okay, good. So that's still working. I think I'm only using new row in one place, so I can actually just replace it with its value like that and just get rid of the identifier. So that'll kind of clean it up. The logic is still the same though. I do wonder if I can get away without nesting a comprehension somehow. Let me think about this. Oops. Let me think about this. I wonder if there's a way, because I would rather not nest a loop if I didn't have to. I'll copy this. Okay, so if I did for the character in the row, I guess it's just I'm replacing each character with a duplicate of itself. But in order to do that, I need to examine each character. Huh. I could maybe run through the whole string. But that's essentially what I'm doing. It's kind of funny. This is a nested for loop. But if I look at this, it's, give me the row and then look at each character in the row. So I think this is as many loops. I think this is still O of n in a weird way. I think technically it's not O of n, but it's still like I'm still looping. I'm still performing as many iterations as there are elements in the string. But I look at this nested for loop and I'm like, oh shoot, I'm doing duplicate work. I mean, sometimes you have to nest a loop inside another loop, and there's no way around it. But or the ways around it aren't obvious, or they require a whole different way of thinking about it. But in this case, I think nesting this loop is kind of an illusion. Basically, this is a looping structure that examines every character, but the nesting just kind of adds a layer of convenience because I get each row individually, and then in the row I look at each character, and then I go to the next row, look at each character. And that's the same as just looking at each character, including the new lines. But this way I don't have to have special logic, like if the character is a new line, then I do something else. So I think this is about as efficient as that's going to get, I think. Okay. So true, true, true. Okay, good. So this still works. I could just return this value directly, and I don't have to do this transform here. And I wonder, does this still need to be there? I think it does. It does. Okay. And then, I guess I could turn this into a comprehension. It'll be a nested comprehension, and it'll be ugly as all get out, but it will be a comprehension. So I don't know. We're getting into that point where I usually think like, this maybe is better left as not a comprehension, because it's going to get, this is turning into a pretty nasty, pretty dense line. This is a heck of a line of code. You just return that. Okay, I got it onto 2 lines. Let's see if it's going to work. And we definitely broke it. Okay, we're definitely breaking it there. Ah. Ah, okay. I see. I replaced the whole thing. I needed to just replace that. Let's try that. True, true, and true. Let's cut these out. Okay, that's better. Now let's try to submit it again. We'll do attempt. We'll just see. Looks like it ran, and I think it maybe ran a little faster too. All right, well, I still have that nesting going on. I bet there's a few methods that I could use to optimize this and make this cleaner, but you know, it does work. I think my favorite state of this is this, where we have the one comprehension here, but just the regular for loop. I think this is kind of the best version of this particular solution. Not that this is the best possible solution, but it's just my favorite. It's a good balance between like clean and readable, and some optimization. So I'll hit submit there, and then let's look at other folks' solutions here. Let's go back up to here so we can look at everybody else's solutions. This looks pretty kind of suspiciously similar to the way I did things. Words and string dot split, although they don't have an edge case, so ooh, this looks really nice and elegant. That's probably the way to do this. This says words equals string dot split. That's going to split on everything. I guess it's going to split on new line characters. Excuse me. It's going to split on white space characters, and the only white space characters in this string are new line characters. So I would put a new line in there. I think that would be the thing to do. Then this says words H, I guess that's for horizontal, is going to be string dot join char times k. That's what I did for k, or for char in word, for word in words. So that's actually a nested comprehension. That totally is a nested comprehension. So it's saying do this comprehension for this word in words, which is itself a comprehension. So that's still nesting. And then new line dot join on new line dot join word for blank in range n for word in words h. Oof. There are two nested comprehensions in this. This is kind of a funny thing, right? This looks like this solution has the most votes as best practices and clever, but it had twice as many repetition structures as I did, and I kind of feel like I didn't even need that many. It looks like this person did what I was thinking initially, which was to break out one of the scaling. I was thinking maybe I could break out both of the scaling directions into their own functions, but they broke out one of the dimensions. Yeah. So you can kind of look through here. You might see some ideas that you like. And it looks like my solution is like fairly on par. I'm seeing a lot of nested loops. Seems to be how, here's another comprehension, nested comprehension. It's in a lambda, of course. But yeah, I'm seeing a lot of kind of nested loop approaches. So that gives me some confidence that like maybe my approach wasn't so bad. Maybe I should have a little more faith in myself. So, cool. And I think maybe just for fun, I'm going to try this again, and I'm going to do the super dense solution. I find this code to be funny myself. I'm going to attempt. I wonder if it'll get voted up. We shall see. It probably won't. This one's fairly old, so. Okay. Cool. And then from here, you just go to kata again and do another one. All right. Let me catch up on questions here. Yeah, it's just one. It's like building a logic map, even if you have to draw some new paths. You already have a lay of the land. Yeah, I think that's probably a comment from when I was talking a little while ago. Yeah, I think that's a great way of looking at it. It's like you try to get a lay of the land, try to make some good educated guesses, even if it feels a little brute force. You're like, well, this might not be the most elegant way or the best way, but it will get me there. And that's actually a really I think that's a I I basically when I see people kind of get over that you know thing of like, oh, it has to be the best solution versus just like I just want it to work. I see them kind of go from that's a lot of times that's kind of a big skill shift, because it enables you to just get through things, right? Um, you know, here's an industry secret is like nobody's happy with the state of their code. Everybody, like you'll write something and it'll keep you up late at night. Like I know I could have done that better. And everybody's doing this, and you'll have an epiphany at 2 a.m. and you'll grab your computer and be like, I have to rewrite this. So that epiphany will come. The optimization will come, but the start is just getting that solution. So yeah, just getting a lay of the land. Like I think thinking about it as a map is a great analogy. I hope that I actually took that question in its correct context. But all right, that was fun. I like talking about testing. I like it because um, I like it because it's one of those things that like makes coding feel kind of straightforward. I think there's kind of a little bit of a lift in understanding why would I want to like put a bunch. I mean, you saw how much time I put into like writing the tests before I even got into the solution. I don't know. I haven't timed this, but I had a guess. I don't know. I might have spent as much time just putting together the tests than the solutions. If I were doing this on my own and not, doing it as an example, it would have gone a lot quicker. But I want to take my time and make sure, give people an opportunity to ask questions, um, and give people an opportunity to kind of like, watch me do this slowly. I'm not just throwing a bunch of stuff. I still worry that maybe perhaps I'm going too fast. Excuse me. My eyes sometimes act up, which is what's happening now. So, that process will go faster. I guarantee it, it will go faster. Once you get into a rhythm with it, once you get a little more comfortable with it, once you have a clear idea of why and what you're doing with testing. But honestly, um, with problems that are challenging for me, problems that challenge my growing edge as a programmer, it isn't uncommon that I'll spend more time writing tests than actually like writing the code. And the reason for that is, I mean, I've like bigger problems, where I'm not just writing one function, but I'm writing, you know, um, a part of a feature into a project that I'm doing, and I have to write a number of things, and like I just go through and I'm like, well, I know I've got to do this and this and this and this, and I go through and I just write unit tests for whatever I don't have to like, for whatever I'm certain about. I don't know, I might spend 2 or 3 hours doing that, or I might spend an hour just writing tests and then 30 minutes, 40 minutes doing the actual work. So that's a total time of maybe, let's say, an hour and a half, an hour 45 minutes. if I don't put that hour into writing tests, I could easily spend 2 or 3 hours just writing the code with no tests to help me. You know what I mean? So in on the curve, it's way faster. Um, but I think people have this. A lot of folks have this thing where it's like, oh, okay, right. I'll just get some tests down really quick, and then I can get to the good part. And it's like, no, the testing, it kind of is the good part. I really enjoy writing tests because that's the point at which I'm really like thinking about kind of the maybe the philosophy of the problem. That's where I'm kind of doing the interesting thinking, and then I get in, or it's where I'm doing an interesting kind of thinking. I'm kind of thinking about what this is supposed to do. Okay, what about this circumstance? What about that circumstance? And sometimes it's a judgment call. Well, what do I want it to do? I get to make that up, and what are the implications of those decisions? So it's kind of an opportunity to design a little bit, and to look at the big picture and to consider the details, and I think that's fun, and it's a part of the problem that you don't want to miss out on because it's fun. And then when I get into the actual problem solving, then my thinking goes from the kind of bulk philosophy of what this problem is to like implementation details, which is also fun. Um, but then often the thing that's blocking me from solving the problem isn't that, at this stage, isn't that I don't know the language. It's that I somehow I don't fully understand the problem. So the implementation details are the straightforward part, and that's different for me because I know Python. I'm already comfortable working in this language and doing what I need to do in it. And if you're just learning, it's still useful to put that time into testing, and you'll find that balance. Put that time into testing because um, then when you're actually writing your code, the only thing you have to think about is implementation details. If implementation details are still something that you're learning, right? You don't want to be doing like thinking about what this function should do, what it might do, what you want to reduce that. And it's not that you won't, and it's not that all your tests should always exhaustively check every possible thing. It's just they should get you they should get you to the point where you kind of have some momentum to get started. You have something to work against, and it'll make your life easier. So if you don't want to spend a whole lot of time testing, if you still don't want to, just write one. Make yourself write at least one. One is infinitely better than none. So yeah, I would say just write one, and that'll at least give you something that'll run your function, so you can play around with it as you work through it. So um, yeah. Yeah, okay. I think that's clear. I'll stop repeating myself at this point, but all right. Well, we're an hour into this already. I really did take my time with that problem. That's okay. I do like kind of just going slow and talking through things. So yeah, if anybody's, just quick reminder, if anybody's got any questions regarding a topic and learn, feel free to throw that in. I worry that sometimes people might think they'd be interrupting what I'm doing if they had a question, but yeah, I mean that really is the primary purpose of the study halls, is to give you all a venue to ask the questions. So yeah, since I'm not seeing anything, we have a little less time at this point. Oh, somebody says they got a question. What's your question? Stuck on a learn problem. Cool. Throw in a link and it, yeah, feel free to ask it. Ask away. Alright, we got a link. Copy that link. Copy this. Copy. This says that's the second question below is the code. Okay. And then let me navigate to that. Oh, actually, I just turned off the browser, but why don't I turn that on? I'll just go to the question in here. Nope. Let's see. There it is. Here's the URL. Okay, open-ended problems, second question. So this is all about while loops. First couple, actually. Okay, we could just go through all the challenges for this one. So it looks like you're on the next prime and the wondrous test. Ooh, I like this problem. I have fun with this one. And then the wondrous test. So I forget forget if we are including is prime with this one. Complete the function called next prime. This function takes a single parameter called num and returns the first prime number larger than it. Note, this function will only take one positive number. Okay, so I see right away that you're starting an is prime flag, which is, there's a way to do it this way. I find it, I'm going to leave your code here and comment it out. And then I find it a lot easier to write is prime as a function. So is prime, not next prime. And then, yeah. Sorry, we're doing these out of order. Is this previous one? Is this relevant? No, this is wondrous test. Okay. So rather than writing is prime, like as a variable with a flag, and then doing the logic to determine if a number is prime, in here we'll do is prime as a function. So I'll say def is prime. We'll take an n, and I'll pass for now because I totally remembered to write tests. I didn't forget at all to write some tests. Don't think that I did. And we'll just test up to 20. We'll test 0 through 19. So I want to test every number between 0 and 19. So I'm going to test this actually in a loop like this. I want to say print. And then I'll say I, comma, is prime, I, like that. So right now I'm getting every number. So, when you this is another thing, we've been talking a lot about, I've been talking a lot about tests today. So we're getting into, on the note of test-driven development, there's an idea of red, green refactor. So you start your problem by writing your tests. You run your tests to make sure that they can fail. If your tests cannot fail, they will not give you an accurate signal when they rightly pass. So you want to check, you want to test your tests. So, this is just a pre-test of our tests, pre-flight check, right? So you can see we're getting output, and wherever we're seeing none, that's because we're calling the function. It doesn't return anything right now. And what we want to see there is true or false, right? So we'll see each number and then true or false as to whether that number is prime or not. We got some comments here. So regarding the code sent in, the person who sent in the code is saying, gets past the first prime, but then gets stuck. Oh, first couple. That's what you meant. The first couple. First couple primes and gets stuck. No, I mean it gets through the first couple primes. I see. It just sees 7 as prime. Yeah. Yeah, I'll go through this solution with the function broken out like this, and hopefully it'll be clear kind of like what the logic is. I'll rewrite it with is prime in there, and then we'll juxtapose that solution against your code here, and we'll see, like, we'll kind of see where it went awry. Cool. So I've got my is prime function started, and so for this, I'm just going to say for I in range 2 to n, and we don't need to check every number. So the reason I want to start at 2 is I'm going to use I to divide n by, right? I'm going to say if n over I has a remainder of 0, so I'll test with the remainder. I'll say mod I equals 0. So what this says is if n over I has a remainder of 0, then I know I is a factor, a valid divisor of n. So I don't need to check. So the reason I want to start at 2 is if I start at 0, n over 0 is an error actually. I'll show you this. Oh, we got an indentation error. Fix our syntax. So this is a 0 division error. We have an error just explicitly for this one specific thing. You can look into this. Dividing by 0 is a whole thing if you don't know about it. You can't do it. Some people say it's infinity. Some people say it's some other, we're splitting the number line. There's some debate about what this is. So Python's opinion is I don't know what you want me to do. I'm not going to do that. So it doesn't divide by 0. It gives us an error, which is it's a good thing to do. So we want to avoid dividing by 0. So if we started at 1, the problem is n is divisible by 1, even if it's prime. Every number is divisible by 1, so we don't want to divide by 1 either. Not every number is divisible by 2. Numbers that are divisible by 2 are even numbers, so if it's divisible by 2, we'll catch that right away. So we'll start at 2 and we'll go up to n. The thing about divisors is they come in pairs, right? 10 over 5 is 2. 10 over 2 is 5. And this is actually a good example. We don't need to check past half, right? We don't need to check past half of n, right? Because we don't need to see if n is 10, we don't need to see if n, well, this won't actually check past 5 because 10 is an even number, so it'll be true if it's 2, and we'll determine it's not a prime number right away. But we don't need to, let's say for 11, right? We don't need to check past 5.5 because we don't need to see if 11 is divisible by 9. It can't be, right? It can't be divisible by a number that's more than half of itself, right? So we could do this. We'd have to cast it as an int. But we can even go further. We can say, since all of those pairs of numbers, the upper part of the pair can't ever be more than exactly equal to half. We don't even need to go, the lower part of that pair is going to be even lower than the half, right? So all the lower parts of divisor pairs are going to be less than or equal to the square root of that number. So the highest lower pair of a number is a number's square root, right? And in that case, the square root is the upper and lower pair. In other words, we multiply a number by itself we square it to get the square root of whatever other number, right? So I can reduce this even further by raising n to the power of 1 over 2. In this case, I do have to include this boundary. So I have to say plus 1. I'm making it an int because I can't use a float in a range. And I'll just trunk any decimal point value for odd numbers and then add 1 to make sure that that next one is included, so I have a little bit of a buffer. Okay, so let me make sure I did this right. Put in some spaces. That's nice. Int in square root. Good. That looks good to me. Okay, so we'll reduce that range. That's just a little bit of an optimization so we don't check too many numbers. There are some other optimizations that we could make, but it starts to get more complicated. Okay, so if n mod I equals 0, we know I is a factor of n. And if this condition is ever true at any point, we can just return false. Or excuse me, yeah, false. This number is not a prime number. If we find a factor of n, if we find an I value that is a factor of n, we know it's not a prime number. If we make it through this whole loop without returning false, remember, as soon as the function encounters and runs that return, it stops executing any code. It's just finished executing code. So if this condition is true, it returns and it stops. It won't even execute any more iterations of the loop. It just stops. If we make it through that whole loop without stopping it due to a return, we can return true, like this. We do have an edge case that I'm just going to say if n is less than, less than 2, we're just going to return false. We're just going to say 0 and 1 are not a prime number. Okay, cool. So let's just run this really quick. We've got 0 and 1. These are our edge cases. Those are false. 2 and 3 are prime numbers. 4 is not a prime number. 5 is a prime number. 6 is not. 7 is. 8, 9, 10 are not prime. 11 is. 13 is. 14, 15, 16 are not prime. 17 is prime. 19 is prime. Great. So that looks right to me. Feel free to let me know if you see an error in there. But I think that's right. Cool. We'll just get rid of the test. And now we'll do next prime. So let's say maybe, yeah, I'm just going to change this to next prime. Def next prime, we'll take in n. And so here's the thing. While, usually when I write a while loop, I just want to get into the logic. So remember, while just takes a condition just like an if. So while and if have a similar way of we could describe them similarly. They both check a condition. If the condition is true, they execute the code in the body. The difference is that once an if is finished executing the code in the body, it just moves on. It just keeps going down the line. Whereas a while loop comes back up and checks that condition and asks if it's still true. And if it's true again, it will run the code in the body again. And it will do that either until the loop is broken by a break or a return, or until this condition evaluates to false. In this case, we're going to give it a condition of true, right? So remember, a condition is any expression that evaluates to true or false. Well, true is an expression that evaluates to true, so it's a valid condition, right? What this effectively says is loop forever. Loop forever. Just keep looping. And I like to start my while loops this way because often, like when I'm here, I just kind of get like programmer's block. I'm like, what is the condition that needs to stop under? What I usually just want to do is just get into writing it, and it will become clear when I need to stop it, right? So I need to call my isPrime function, and basically just say, if the number, if is prime of n, and we need a value to accumulate on, and I could do something like counter equals n, and then counter plus equals 1, but I don't even need counter. I can just use n directly, which might feel counterintuitive. It might feel wrong because n is our input, and there's all this, like, don't mutate your inputs. We are always saying don't mutate your inputs. The reason for that is you don't want that change to your input to propagate back to like whatever you passed it, right? So if I had a variable that represented n, a global variable, I pass it to the function. I wouldn't want that variable value to change if I pass it to this function. But that can only happen with mutable data types. Integers are immutable, so we can't actually cause that kind of change. It can't back propagate to the to its argument being passed. So we're actually safe to do this. We will lose the original value of n, but it's not doing us any good because what we need from it is we need to check the next number and see if that number is prime until we find a number that is prime. So we'll just say while true, just loop forever, just increment n by 1. That way we don't check the value of n. The reason we don't want to check the initial value of n is what if n is a prime number, right? If I pass next prime, if I pass it a prime number, if I pass it 11, which is a prime number, I want it to return 13, not 11. So the first number I want to check is the number after n. So I want to check if 12 is a prime number. Obviously 12 is not a prime number, so then we'll check 13. So if n, n plus equals 1, we'll do that first. So if n is 11, n is now 12. Then if 12 is prime, return n, just like that. Since I know primes are, there's an infinite number of primes, eventually I will encounter a prime. I don't really need to worry about an exit condition for this. I can just let this run until inevitably it encounters a prime number, and then return that number, like this. So this should work. Now, if I wanted to go submit this into learn, if you wanted to do the two functions like this, you'd have to submit both functions just like that. Run tests. Nope. Cool. So that's one way to do this problem. And this is kind of my preferred way. Now I know this is kind of going a little bit off the rails because I've got this whole other function in here. If you did want to do this in one go, we could kind of rewrite this. We could say we could do something like n plus equals 1, and then sort of copy in this logic here. We'll need to get rid of these returns. So I'll need to say is prime equals, I think I need to start it at false. And then every time I encounter a return, I'll change it to is prime equals. Right? And in this case, I can break. Since I don't have the return breaking this for loop, I'll break there. And then if I break there, see, that's what I need to do. I need to start is prime at true. So then that way, it's a matter of, do I set it to false, right? So if I set it to false, then it's false. if I make it through this whole thing without setting it to false, then it remains true. That's what it is. And then I can just check this is prime flag like this. So this should work similarly. Now let's see. I know the previous version worked, so I'm actually going to copy this. I'm going to copy that so I can examine it, the output, when I get into it. Okay, so we'll see. So 0, the next prime after 0, and 1 is 2. Next prime after 2 is 3. After 3 is 5, and 4 is 5. After 5 and 6 is 7. 5 and 6 is 7. Okay, after 7 is 7, 8, and 9, and 10 is 11. After 11 and 12 is 13. After 13, 14, 15, 16 is 17. After 17, 18 is 19. And after 19 is 23. Cool, that looks like that worked. So if I wanted to get this in one function, I could do it that way. But it's sort of the trick here is, I always guess at this. This is one of those things, I do this a lot with Booleans, like when I'm initializing a Boolean value, and I know like I've got a flag, and at some point I'm going to need to change it to true, and at some point I need to change it to false. I don't know if it's just my brain, but I often find it really difficult, like in the moment when I'm creating it initially, to determine whether I need to start it at false or true. I never really remember, so I don't really try to. I just will guess, and then what I remember is the places where I made a guess, right? So I'll go in here and I'll just be like, oh, maybe it needs to be false. And I guessed wrong there, and I got through here, and I'm like, well, what do I do about that return true? You know, if I made it through here without returning false, or without setting is prime to false, I need is prime to be true. So that just means, oh, I just need to start it at true. And I'm like, okay, so, you know, getting through the rest of the problem sort of helped me think through that guess, whether that guess was right or wrong or not. And whether the guess is right or wrong or not doesn't save you from having to think through the problem eventually anyways. So, you know, might as well not put like a whole lot of stock in that guess, you know. Just take a guess, whichever one. Just remember that you made a guess there, and then kind of think through the problem, and then that'll tell you where you need to start that. So I think that's kind of the crux of that one. So this one should work on its own, just like that. And that one, oh, did I run that? Sorry. Yeah, I did run that. Good. Cool, so let's actually look at your code here. And let's kind of see where it diverged. Cool. Yeah, I hope this is helpful for you. Okay, so like let's look at this. Write code below. So you've got is prime is false, while is prime equals false. That seems rational. I think that's probably gonna do it. I would say the more conventional way is to just invert it, while not is prime, while the number is not prime. Num to grow equals num. So I imagine this is your counter. Yep, looks like this is your counter. That's good. For each, so that's your element. I'm going to rename this I because that helps me. So for I in range, 1 to num to grow minus 1. Yep, that's good. So if you go check the whole range, you need to do the n minus 1 there. Or actually, you can do n because it will be 1. It's the upper bound in a range is excluded anyways, but you could do minus 1 there if you wanted to. And then I think this part is looking suspicious to me. I think it's sort of a matter. Sometimes I like to do this, like put a little fence around where I'm working. I think of it like kind of like construction cones. Um, like this area under construction. If I've got a lot of code and I need to work on a specific part of it, I'll do this so I don't get lost, right? Like I can say, okay, so this is the part of the code that I'm like working on. The other part is good or whatever. So I think we'll take your is prime up here. I think this has to be down here. In mine, we did discover that this had to be true as well. And I think, you know what? I think you're right. Up here, we've got to set it to false. And that's because you're using it to gate your condition. But we have to reset it at some point. We have to be able to reset it and actually check it. And then here, num to grow mod I equals 0. That condition is good. So if this is the case, you're saying to continue. And I think that's because you were assuming is prime is false. And then you're saying else is prime is true. So the thing about this is going to give false positives. When you have an if-else always says, always has this effect of one of the bodies of those, one of the consequence of those conditions is guaranteed to be run. If this condition is true, we run the if code. If it's false, we run the else code. So it's one or the other. One of these is guaranteed to be run. So with numbers that aren't prime, right, like 9, the first number we're going to check, actually, this is going to say every number is prime because we're starting at 1. We want to start at 2. So the first number we're going to check, so that would be one problem. But the first number we're going to check would be 2. 2 is not a divisor of 9. So this is going to be set this to true. And then is prime is going to be true for 9 from there on out. So yeah, that's why that won't work. So in this case, we'll just delete that. And then I'm just kind of inverting the logic a little bit. Starting this at true and then setting it to false. And then if it's not set to false, then we can go from there. Cool. So this would read as we'll start is prime as false, and then while not is prime, we'll increase the number to grow by 1. It was good that you did that. Then we'll check it in here. We'll assume the number is prime, and then we'll check every number until we find one that's a divisor. If we find a divisor, we know it's not prime, and we can save ourselves some work by breaking. We can say break, because we found a divisor. We don't need to run this loop anymore. Break will act on the loop that it is most immediately inside of, so that'll act on this inner for loop here. So that should work as is. Let me just test it, and we'll see if it does. Correct. Cool. All right, well, it's a good solution. I would say you're pretty close. You had most of it down. Just a couple details. I think, thinking through that range of where you want to start is helpful. Like you don't want to divide by 1 because every number is going to be divisible by 1. And then it looks like you just got tripped up on the like when and how to flip, when and where to flip the Boolean false to true, and that's fair because that's like always kind of a confusing thing. Cool. You couldn't see it, but it was nodding along. Okay, cool. Yeah, I assumed I assume everybody is nodding along because I'm excellent at what I do. So you know how entertaining I am. What a privilege it is for you all to be listening to me. Okay, no, I'll stop. Anyways, yeah, cool. Looks like we're at our usual stopping point. Thanks for bringing in the question to the person who brought in the question. Do appreciate that. Feel free, everybody, feel free to bring in more questions as they come. Yeah, that is like the primary purpose of study hall, and I'm happy to take questions and keep doing it. So, yeah, it was a pleasure. I'll wrap up here, and I'll see you if you're in premium prep. I'll see you tomorrow, midday Saturday, or I'll see you on Monday for the next study hall. Cool. All right, y'all have a great rest of your evening, and I'll see you around. Bye bye.